So we're going to get into graphing quadratic inequalities today. Yesterday we were practicing just linear inequalities, so graphing straight lines, deciding if it was solid or dashed, which side of the line you shade on. We're still going to do all of that stuff today. The only difference is that instead of having straight lines, we're going to have quadratics. So we're going to have parabolas. So you're going to have those curved shapes like we saw at the very beginning of this chapter. So some of the graphing, you'll have to think back to what we did at the start of chapter 2. We'll use some of those same things to help us graph these. So in order to graph your parabola, remember you want to start by finding your vertex. That's when we did negative b over 2a. Because that really helps us find the center of the parabola so that then we can look at points on either side of that vertex. And that'll give us points on the left and the right side so we can see where the graph is going to go. Remember, parabolas should be symmetric. So if you've got a side on the left side, like a point, there should be a point reflected over the vertex on the right side as well. They should be matching on both sides there. You don't need to have a ton of points to graph these. Okay, so just like before, you just need a couple points to kind of see where your quadratic's going, whether it's opening up, opening down. And then the rules are the same. As far as whether your line is going to be solid or dashed for your quadratic, it's based off of that inequality sign again. If there's no equal sign, then it's going to be a dashed line. If there is an equal sign, then it's solid. And then shading, we talk about it being like above or below the parabola. And another way to think of that is like inside the parabola or outside of the parabola, because they're all going to have that curved U shape. And so you're either going to be shading in the middle of the graph or outside of the graph. But that kind of does the same rules. Like if it's greater than, you're going to shade above the graph or inside the graph if it's facing up. And then if it's less than, then you would shade outside the graph. Again, that's facing up. It changes a little bit when it flips and it's upside down. So this first one, if I look at the equation, says negative 2x squared. So that negative 2 tells me right away that this is going to open down. Because we talked about that first number. If it's positive, it opens up. If it's negative, it opens down. And then we have minus 4x plus 6. So we start by doing negative b over 2a. Which number is in the b spot? Negative 4. So we're on the top, we're going to do negative of negative 4. That's going to end up becoming positive. Over 2 times a. A is a what? Negative 2. So on top I have positive 4. On the bottom there it's negative 4. So 4 divided by negative 4 would be negative 1. So to make a XY table, and this is when you guys can use the calculators again, like I showed you, to type in that function in the table and then just look at the points, or you can type them in like individually. But you put negative 1 in the middle, because that's the vertex, that's the center of the graph, and then pick some points above and below negative 2. So below negative 2 would be, below negative 1 would be negative 2, negative 3. Above negative 1 would be like 0 and positive 1. So if you have a calculator that can type in the function for you, like the yellow ones can, it really makes this process a lot easier on yourself, so you're not having to type in like every single thing with the parentheses and you're making possible mistakes. Yeah. You do not. Well, are you typing it in the function or? Yeah, no, you don't need to. You should just be able to do negative 2x squared minus 4x plus 6. Okay? So if you don't have a calculator that can have you type in the function, then you will have to make sure that you're putting parentheses around things. So if you're typing this in manually, here's an example of what it should look like. Negative 2, parentheses, negative 3 squared, minus 4, parentheses, negative 3 plus 6. So all the numbers in the parentheses are what's changing. So then you would replace it with a negative 2, with a negative 1, a 0, and a 1. Negative 1 would be a good starting point. Yep, because then if you're on the calculator like that, you can just move up and down through your table, and it really won't change things. So if you're doing this, for -3 you should get 0. For -2 you should get 6. -1 is 8. And then they're going to start repeating that process. So 0 is a 6, 1 is a 0. So that gives you some good points, kind of a good idea of what this graph is going to look like. So I'm going to go ahead and graph this now. So we've got -3, 0. So go to the left, -3. -2, +6. -1, 8. 0, 6. And then 1, 0. Now, for graphing the line, look at your inequality sign. So it's less than or equal to. So this should be a solid graph, no dashed line when you do this one. You should go ahead and just draw it in. And we want less than. So I said that it kind of changes when the graph is upside down. Less than would be below the graph, which is contained inside the parabola. So you're going to shade inside that curved V shape. Okay, if we go on to the next page, we've got another one here. Y is greater than x squared plus 4x plus 1. Starting this the same way, we're going to do -b over 2a to give us our vertex so that we kind of know where to start. What number is your b for this equation? 4. Good, 4, and a would be 1. So we have -4 over 2, which is going to be -2. So that goes in the middle of your table. And then pick some numbers above and below. It's like -4, -3 would be below -2. Greater than -2 would be -1 and 0. Okay, so I'll give you about a minute or two to fill out your chart there. Find those numbers. So if you're, again, typing this in, I would be really careful. Make sure you're putting parentheses around things. So for example, parentheses around -4 and then square it. Plus 4 times -4 in parentheses and then plus 1. Can you guys tell me what numbers you're getting?
1, -2, -3, -2.
Good. If you're not getting those numbers, you need to check how you typed it into your calculator. Because it could be that you didn't use parentheses, or maybe you switched a sign. It's super easy to switch a sign accidentally from like positive to negative. It happens all the time. All right, so now let's graph these points. Is this graph going to be solid or dashed? Good, dashed. Now, if you like to draw it in solid first and then go in and kind of erase points of the graph, you can. I see a lot of students do that because they don't like to do the dotted because they get kind of sloppy. So do whatever works best for you. Now, we want to shade above this graph. So when it's facing open like this, you shade inside the graph. So you're going to shade inside the parabola. So there's one more here on this page. I want you guys to try to do the whole thing by yourself. Yeah. Because the last one was upside down. So when it flips upside down, everything inside of that is going to be smaller than everything outside of it. Another thing I like tell kids if they're really struggling with like where should I shade, pick a random point on the graph anywhere. So let's say I pick this point right here. Whoops, drew my arrow wrong. So this is at 1, -1. What I do is I take that point and I plug it into my equation up here, this one. So I do -1 for y greater than 1 squared plus 4 times 1 plus 1. And what I'm going to do here is see, is it true or false, the statement that I get. So -1 greater than, on the right side here, you'd have 1 plus 4 plus 1, which would be 6. Is -1 greater than 6? No. So this is false. That means that I don't want to include that point in my solution set. Yeah. So that would be a way to check if you're not sure where to shade. Pick a random point anywhere on the graph and plug it into that equation. If it's false, you do not include it in your shading because it doesn't work. If it was true instead, then I would include it. So then that tells me I should shade that area, if that helps. No, you won't have to write if it opens up or down. All right, go ahead and try number 3 all by yourself. Your vertex point is a decimal. So when you guys get your vertex for this one, did you get 3/2 for your x? So that point's going to be a decimal. You'll have to estimate where that's at. When it goes to filling out your chart, you do not have to pick other decimals. You can pick whole numbers that are around 1.5. So numbers less than 1.5 would be like 1, 0, -1. And greater than 1.5 would be 2, 3, 4. If you pick decimals, that's okay, but you don't have to. You can make it easier on yourself. So what'd you guys put in for your B term? Positive or negative? So it should be negative because you've got negative 3x there. What's the A term? 1. So we've got positive 3 over 2. So this is what I was talking about, that yes, your vertex is at a decimal or a fraction point. You can think of it as a decimal fraction, whatever works better for you. But you don't have to pick other fractions as other points to test in this equation. This is when you should make it easier on yourself and pick whole numbers. So like 0 and 1, 2, and 3. So when you plug those numbers into your equation up here, you should get 5, 3. 3 halves is 2.75 as a decimal. And then 3, 5 repeats itself. So when you get started, you will have to estimate where that vertex point is at. And that's just, you'll have to do your best at figuring out where you think it should be on the graph. It does not have to be perfect, but it should be fairly close. So we've got 0, 5, 1, 3. So 1.5, and then up almost 3, but not quite. 2.75. Then we've got 2, 3, and 3, 5. So my vertex is really close to those other 2 points in the graph. Is this one going to be solid or dashed? Good, solid. Okay, now this one opens up, and I want everything less than. So where should I shade? On the outside. So out here. And again, how could you decide that if you weren't sure? Pick an easy point. In this case, pick 0, 0 because it's not included on the graph. Let's put 0, 0 into our function up here. So we put 0 in for y, 0 in for all those x's. You're going to end up with 0 less than or equal to 5. Is 0 less than 5? Yes, so this is true, which is why I know I want to shade including 0, 0. I want to include that in my solution set, so I need to shade on the outside of the parabola. So with the parabolas, the shading is probably the piece that's going to take you the most to try to figure out a little bit, because it does change whether it's opening up or opening down. But if you need to, pick a point. And if 0, 0 is available, I would always pick that point because it's the easiest one to work with because it's just a bunch of zeros. But if 0, 0 is on the graph, maybe try to pick a different one, because sometimes then it can kind of cause an issue when you go to plug it in. So try to pick a point that's not on the actual parabola. Okay?